Today's session is about application of differential equation of first order. Here we shall discuss mixing problem. First, let's understand the concept of mixing problem. Consider a tank filled with salty water, brine. Inflow of more salt water. In this inflow of salt water, concentration of salt may vary depending on question given. It can have concentration of salt more or concentration of salt less. Inflow, let brine with salt concentration C in is flowing in at the rate R in. Outflow, brine with salt concentration C out is flowing out at the rate R out. The volume of brine in the tank at the time t is Vt. Vt may change if the rate of inflow is different from rate of outflow. The amount of salt dissolved in water in the tank Xt. Xt will change as inflow of brine may have more or less amount salt than the brine flowing out. Xt is the amount of salt dissolved in water. Rate of change of x, the concentration of salt solution, at the time interval t. Delta x is equal to C in times R in times delta t minus C out times R out times delta t. This implies dx by dt is equal to C in times R in minus C out times R out. Note, C in can be controlled, concentration of salt water flowing in can be controlled, R in, rate of flow can also be controlled, R out, rate of brine flowing out can be controlled, but concentration of brine water flowing out cannot be controlled. It is determined by the quantity salt in the brine and the volume of brine. So, C out is equal to xt by Vt. Ordinary differential equation of xt is dx by dt is equal to C in times R in minus R out times xt by Vt. Example 1. A large tank is initially filled with 100 liters of brine in which 1 kilogram of salt is dissolved. Brine containing half kg of salt per liter is pumped into the tank at a rate of 6 liters per minute. The well-mixed brine is pumped out of the tank at a slower rate of 4 liters per minute. Assuming that the tank does not overflow, find the amount of salt in kg in tank after t minutes, t greater than or equal to 0. Solution, given, C in is equal to half kg per light. R in is equal to 6 liters per minute, R out is equal to 4 liters per min, Vt is equal to 100 plus to t liter. 100 liter is the given and rate of flow in is 6 and out is 4. So at time t, salt water present is 6 minus 4, that is to t plus 100. We have to find out xt. We know dx by dt is equal to C in times R in minus R out times xt by Vt. Plugging in the values, we get this. Simplifying, we get this. Rearranging it, it is in the form of first order linear equation. It is in this form, so integration factor here is e to the power integration of 2 by 50 plus t. Integration of 2 by 50 plus t with respect to t is 2 is constant. Hence taking it out and integrating 1 by 50 plus t is ln 50 plus t, comma. It can be written as e to the power ln 50 plus 2 whole square. Simplifying, we get 50 plus t whole square. We know general solution is given by this formula x. If is equal to integration of q times if dt, plugging in the values and integrating and simplifying, we get this. Particular solution is calculated based on the initial condition, that is, initially tank is filled with 100 liters of brine with 1 kilogram of salt dissolved. So, amount of salt in the salt water is 1 kilogram, x of 0 is equal to 1, that is amount of salt at the time t is equal to 1. Putting t is equal to 1 in general solution, simplifying, we get the value of C. Plugging in the value of C in general solution gives particular solution. Example 2. A lake with volume 8 billion cubic feet is polluted by nitrates with concentration 0.25%. A less polluted water of 0.05% nitrate flows in at 500 million cubic feet per day. Mixed water flows out at same rate. How long will it take for the lake to reach 0.1 concentration? Solution, given, C in is equal to 0.05%, Rn is equal to R out is equal to 0.5 billion per cubic feet. It is converted to billion as volume is given billion. Volume at time t, Vt is equal to 8 billion cubic feet. Volume is fixed as rate of inflow and outflow is same. X by dt is equal to C in times Rn minus R out times xt by Vt. Plugging in all the values and simplifying, we get this equation, which is first-order linear differential equation. The integrating factor in this equation is e to the power integration of coefficient of x, that is 0.0625 dt integrating if is equal to e to the power 0.0625 t. General solution format is this: plugging values, we get this. Integrating this 0.025 is constant, hence taken out. Integration of e to the power 0.0625 t is e to the power 0.0625 t by e to the power 0.0625 plus c. Bring this e to the power 0.0625 t to right hand side. We get this. Cancelling this out and simplifying, we get x is equal to 0.4 plus c times e to the power minus 0.0625 t. This is general solution. Particular solution is calculated based on the initial condition, that is, initially concentration of pollutant is 0.25%. So amount of salt at that time, T0, is 0.25 times 8, which is 2. Putting the value of x of T0 in general solution and simplifying, we get C is equal to 1.6. Put the value of C in general solution, we get this particular solution. X of T0 is equal to 0.4 plus 1.6 times e to the power minus 0.0625 t. Now to calculate. Time taken to reach 0.1% of concentration, that is 0.1% of 8 is 0.8. Putting x of t is equal to 0.8 in general solution, we get this. Simplifying by taking ln both sides, we get this. T is equal to 22.18 days.